Let us look at proposition number 34 of book 7 of Euclid's Elements. The proposition says to find the least number which two given numbers measure. So let's look at an example. 3 and 4 are the given two numbers. The smallest number that both A and B measures is going to be what? That is going to be 12. And this is also called the LCM or least common multiple. Now, let's see how we can do that. So we have A and B are the two given numbers. Now there are two situations. One is when A and B are relatively prime and when they are not relatively. So let's take the first case. So let A and B be relatively prime. Multiply A by B to make C. And we know that B multiplied by A also makes a C, which means that both A and B measure C. So it's just a question of multiplying these two numbers. But is it the least? That is what we have to prove. So here we are saying that C is also the least number that A and B measure. Let's assume that it is not the least number. If not, let there be as many units in E as there are A's in D, where D is less than C. And let there be as many units in F as there are B's in D. Which means what? Which means these two statements will boil down to D is equal to A times E and D is equal to B times F. And we know based on these two equalities, we can say A is to B is equal to F is to E. A is to B as F is to E. But A and B are relatively prime, which means what? That they are the least numbers in the ratio. Least measures the numbers in the same ratio, same number of times. So since A is to B is equal to F is to E, it means B measures E. Not only that, C is equal to A times B. A multiplied by B to make C. And D is equal to A times E. So again, four numbers. So therefore, B is to E is equal to C is to D. Again, based on these previous propositions that we have already proved. So if we have B is to E equal to C is to D, what does this tell us? We already know that B measures E. And because of this proportion, C will also measure D. But can C measure D? Remember, we said D is less than C. That means C is greater than D. So a greater number cannot measure a smaller number. So not possible since C is greater than D. So that means A and B do not measure any numbers less than C. So C is the least number that both A and B measures. That is the first part of the proposition. Now let's look at the second part. Again, let's look at an example. Now, let's say the two given numbers are 10 and 15. Now, these two are not relatively prime. So, what will be its LCM? Based on our current understanding, we know 30 is the LCM. 10 times 3 is 30. 15 times 2 is 30. And there is no smaller than 30, smaller number than 30, which both of these two can measure. So let's see how we can evaluate this and prove that 30 is the least number, which both A and B can measure. They are not relatively prime. So take F and E, least numbers with the same ratio as A and B. Since they are not relatively prime, we take F and E. which are supposed to be least numbers with the same ratio as A and B. That means A is to B is equal to F is to E, and C will be equal to A times E, and C will also be B times F, because this proportion actually we have seen in one of the previous propositions, given a proportion of 4 numbers, product of extremes is equal to product of means. Okay, so which means A and B measure C. Now we have to prove that C is the least number. So again we assume to the contrary, assuming C is not the least number. So let's take a number D which is less than C. So let D be the least number measured by A and B, such that D is less than C. Let there be as many units in G as there are A's in D, and let there be as many units in H as there are B's in D. What would that imply? It would imply D is equal to A times G and D is equal to B times H. And since both are equal to D, therefore we can say A times G is equal to B times H, which means we can write it as a proportion. A is to B is equal to H is to G. Remember, we already have A is to B is equal to F is to E. That means H is to G is equal to F is to E. Now, since F and E are the least numbers, they measure numbers in the same ratio, same number of times. So what does this tell us? It tells us that E measures G. Now, we know C is A times E and D is A times G. Therefore, we can write it in the form of a proportion. That is, E is to G is equal to C is to D. We have already seen E measures G. And because of this proportion, we can say C measures D. But is it possible for C to measure D? Since D is less than C, C cannot measure D. So, which means A and B do not measure any number less than C. That means C is the least number measured by AB. That is proposition number 34 of book 7 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.